Alright guys, so today I'm going to be talking about XXE and what it is and give you guys some demos and stuff. But first, let me just back up real quick. So I didn't know that this lighting was going to look like this, so I couldn't have picked more worse colors. So I'm going to could have picked purple, that's absolutely correct, purple or orange. So a little bit about me, I'm a College of Charleston grad, and I just graduated like 6 months ago. I'm a cyber operations officer in the South Carolina National Guard. I'm also, in my civilian job, I'm a network security analyst at SPAWAR, and I'm also a technical mentor and program coordinator for NodeSC, which is a local nonprofit here in Charleston that specializes in technology, cybersecurity, and business entrepreneurship. So you know what I look like if I'm standing in front of you, but this is me as Clyde the Cougar when he got his ring like a year ago, and I've like scooted my butt across the stage at Satilli Theater. It's a little fun fact about me. All right, so the agenda. So today we're going to cover what is XXE. So to understand what XXE is, you have to know what XML and DTDs are and what uses it. Along with that, we're going to. I picked a specific file format because there's many that you can choose from. So one that I picked was from OpenOffice or Office Open XML format, which is essentially just DocX and PowerPoint X and XLX, SLX spreadsheets. How we can use an OpenOffice format file to deliver an XML payload. With that, I'm going to show you a breakdown of a docx file, a demo of Will, I'm going to butcher his name, but Will Van de Vanter's XML tool. So as we see, this is a tool that this gentleman made demoed at Black Hat USA in 2015 that pretty much takes a lot of the tedious work out of injecting these malicious entities inside these file formats and kind of streamlines it a little bit. Then I'm also going to do a simple demo of what XXE is and show how it can be exploited. So my full disclosure is it's my first talk, for one. And then two, I am by no means an expert at this. So this is something that I came across this topic last year when I was a senior here and needed to have a senior research paper, kind of. And I was pointed in the right direction. Kind of, applies to the topic that I was studying at the time. And I just found it's pretty interesting that it's really simple. It's pretty high vulnerable, and it's like really easy to do and to understand. So with that, we're going to go into what is actually a XXE. So it's from OWASP. This is straight from OWASP website. It's an XML external entity attack. Is a type of attack against an application that parses XML input. So when you're inputting a file that is XML based, the thing that's parsing it, going through it line by line to kind of piece it together to see what the actual file is and reconstruct it, that's what it's an attack against. This attack occurs when an XML input containing a reference to an external entity is processed by a weakly configured XML processor. So you can kind of think of it like an HTML has a CSS style sheet that it's not, you can put it in a HTML code, but it's an external thing that it refers to. So normally we would craft a payload that when executed will do various hacker things. So you could do enumeration of your internal network, for instance. You can also do remote code execution. You do lateral movements, and then you can do directory traversals. So these aren't all the things it can do, but these are some possibilities it could do. XXE is usually caused by an improperly configured XML parser. And by improperly configured means that the external entity portion is turned on by default. In a lot of different programming languages, it is in fact turned on by default. So this parser is normally through a file upload feature in a website or application. The demo that I'm going to be using today is a open source business Facebook called EXO platform. It's ran locally, and it's going to show how it can actually be exploited using that. So the next part is bug bounties, right? So this is a pretty pretty hot topic, and it's pretty easy to find in bug bounties. So the first one, I don't know if you can read it, but the first one says how I found a remote code execution flaw affecting Facebook servers in 2013. This guy was awarded $33,000 from Facebook for finding this vulnerability, like just one vulnerability. The next one was how I hacked Facebook with the Word document back in 2014. He was awarded $6,500. The next one was how we got read access on Google's production servers. Was awarded $10,000 from Facebook, and then very recently this year there was a special type of XXE attack on Uber, which 26 domains were hacked through responsible disclosure. Uber gave him like $500, so that's like a huge like gap difference. So what is XML? So XML stands for the Extensible Markup Language. It's derived from a much bigger, beefier language called the Standard Generalized Markup Language. The international standard for defining markup to describe the structure of different types of electronic documents. It's software and hardware independent. It is also extremely lightweight. So it takes the goodness of HTML and being how flexible it is and strips out the pieces that it doesn't really need, that you kind of don't need to use for your type of coding or whatever you're using, and just contains the nuts and bolts. So one key thing to pay attention to is that XML just holds data. It requires another program to take that data in, to transfer it, display it, and or to store it. So you'll see that it looks exactly like HTML a little bit, but HTML is used to display data with the emphasis is on how it looks, whereas XML is used to store data where the emphasis is on what the data actually is inside, right? So taking a look at some stuff, what uses XML? So like I said before, Microsoft Office products, so documents, PowerPoint, spreadsheets, and then Apple iWork products as well, so the Pages, Keynote, and Numbers. LibreOffice, OpenOffice, SVG images, the vector images. There's actually an XHTML and XSL, which is the XML version of HTML and CSS. And then you have HTML5, which is becoming the new standard that is built directly from XHTML. RSS and Atom feeds are also XML based, as well as SOAP for web services. There are many, many more that are also XML based, but these are the ones that are most commonly used. So to understand XML, there's two classifications to it. So XML files they're either well-formed or they're valid. If they are valid, then they're also well-formed. So the rules for well-formed is they must have a root element. There must be a thing that this whole XML file is. It must have a closing tag, so start and close. Tags are case sensitive and they must match. They must be properly nested, and all attribute values must be quoted. But it doesn't require a document type definition, which we're going to cover in a couple other slides what that actually is. So essentially, if you say that your XML document is well formed, then it just follows correct syntax put out by the standards from the people that set forth standards. Then if it's valid, then it's the rules used to determine if it is valid. It's determined by the DTD that is declared. So you could think of a DTD as essentially it has to follow the same syntax, but then it has another set of rules laid on top of it that it must also follow. There are thousands of DTDs out that is either proprietary or open source that people can use. But because XML is so flexible, you can actually write your own. It's a little bit more advanced, but it's pretty cool that you can actually write your own stuff for these things. I think there was something that came up when I worked at Soteria. It came up in conversation that there was this guy on GitHub that had his coffee pot and had all these automated things that he essentially automated his entire life. So if he didn't come to work if he didn't badge in by 9 a.m., it automatically shot out an email to his boss saying, hey, I'm stuck in traffic. I'm on the way. He also had it coded down like to the exact second that he could start his script, and by the time he got up from his desk to the coffee pot, his coffee is already brewed and ready for him to like just turn around and walk back. So XML is that language that you can use for all these different things, because you're actually writing the language itself so that your hardware and software can read it in. Right? So this is a well-formed classification example. You kind of can't read it, but it starts up at the top as you define the XML version 1.0, and then right where above it says Will Muschamp, it says note. So I'm establishing a note. It's going to Will from the head ball coach, Steve Spurrier, with a heading of reminder, and it said you had one job, guy. And that's because Carolina lost today. It did say it was great to be a Gamecock, and I had a super cool photo of Muschamp doing this, but then I had to take it down because today is not a good day to be a Gamecock. So this is well formed, right? So we have open and closing tags for pretty much everything. We got one full entity that is describing exactly what it is. It's a note. We got two from heading and the body as well. It's properly nested. So this would pass well formed. This would clear many parsers, right? And it would actually compile as well, right? So next we have a valid classification example, and then there's actually three of these, but I only put two up here, and I'll explain in a minute. So the first part on public is it's pretty much the exact same thing. The only difference is that it now has a doc type. So a doc type is for a public is it contains four fields. So the first field is whether the DTD is formally standardized, meaning that was it standardized by an organization, right? So for here we have W3C, which is not the World Wide Web Consortium, I believe. They're not a standardized, they're not allowed to standardize things in this regard. However, they are able to create. So that's just what that sign is. If it's a negative equals yes, plus equals no. Second field is the name of the owner who is responsible for maintaining the DTD. So here, W3C, right? The third field is what type of document is being described. So for here, I put DTD note, note 1.0. This is a fake DTD, so I can make it apply to this. It's not, like if you try to Google that, you're not going to find it. But for demonstration purposes, this is what it is. And then the fourth field is the language, right? So it's the EN, I have EN, I can't even read that. And then we have the actual URL link going straight to find the DTD. So when this XML file was to get parsed, starts at the top and works its way to the bottom, it'll see doc type, it knows exactly where it needs to go to get it, it's got the URL, and it'll go out and grab it. Look at this file, parse it, see what it's supposed to do, and say, okay, I now understand how to interpret the rest of this document or the rest of this file that was uploaded. Let me continue with it. So the next one is a private. It's essentially the exact same thing. The only difference is that it's local to that machine, right? So here we have doc type note. So it's normally the second part after doc type is the tag, is the first tag that is encompassing the entire document. So in this case, because we're writing a note, it's actually the name of its note. System means that it's private, and then note.dtd is a location of where it's located at. So this means that it would be in the local directory. If I wanted to point it to a specific file, server, folder, website, whatever the case may be, that's where it would go. All right, so this is what it actually looked like. So the XML code, I can make it look exactly like this. And it's the Steve Spurrier upset because it didn't do well today. So this leads me into the open office format. So out of all of them, this is the one that's kind of, to me, it's the easiest to understand, kind of grasp, and kind of see. So a little background on it. Prior to 2003, Microsoft Office's file format was binary based. Right? It was good for what it did at the time, but then as technology advances, we need something more flexible. So these types of files were designated with the doc, the XLS, and the PPT, right? So in 2003, Microsoft introduced a new format based on XML alongside their binary-based formats called the Office Open XML file format. These are the same things, except they're annotated with the X there, because Microsoft is smart. And then this new format allows Office documents to be used with any application that uses XML, hence the name OpenOffice, right? So what's really cool, I'll get to that in a minute. So the breakdown. So a docx file is nothing more than a .zip file. That's all it is. It's just a zip file with a whole bunch of XML files in it and with folders that house those, you can think of them as buckets, that is splits the XML file apart. So with that, it also includes images. It includes sounds, music, videos, right? So it breaks it down, which we will see here shortly. So what's important to understand is that the file structure itself doesn't matter. The relationship of the individual files that is defined within the docx that make up the docx file does matter. So I know that's pretty confusing. It was confusing to me when I was writing it, and I was trying to think of a way that I could make that simpler, and the only way I could come up with is actually showing you, so that's why I included it. So you can rename and rearrange any part of an XML file. So if you have, let's say you have a business and you have 1,000 documents, and then your company says, all right, we're going through a new rebranding phase, we're going to change out our logo. In the binary form, you would have to go in and open each document and change the logo. Whereas XML, you can actually do like a batch portion of it and say, I want you to navigate to this folder with this file name, and I want you to replace it with this file. And all the document files in this folder start, and it would run through and do it all for you. That's where the power of XML comes into play, because it doesn't. It breaks it down to a level that you can pick apart the things that you don't need. So with that, this is how typical OpenOffice format files are broken down. So you got document properties, which is essentially your metadata. This is the author, the date it was last modified, date it was last opened. And you have any custom defined XML. So this might be XML code that's specific to that file format. You got any embedded code or macros? This will show up here. And then you might have Word markup language, spreadsheet markup language, PowerPoint markup language, etc. will be there. Any charts? So if you can add a lot of smart charts or charts you just created in the document format, so you can put those in there, as well as images, video, and sound files that we talked about earlier, and the comments. So the comments and the markup language, so you have like editing on Word documents. It'll track, oh, I deleted this word and added this word instead. All right. So in OpenOffice format breakdown, there's essentially 3 core folders, depending on what you include into your file, in this case, our Word document. Depends on what folders are going to be there and how big your file is going to be, obviously. The more things you add to it, the longer your document is, the more XML files and the more things you're going to have in it. So the top one is the relationship folder. Now remember, the relationship portion is the key. So it's what ties everything together, right? So it contains a .rels file that defines root relationships within the package being the docx file itself. It's the first place that parses, and you should look at when parsing through a file, right? So I say that because this is where most XXE code is going to be implemented at, is in a relationship file, because it's normally the first thing that gets looked at when it's being parsed. The next thing is the application name folder. It contains the XML files and folders that contain other relevant XML and media files used within the docx. And then a docprops folder, which is the metadata. Right? So now we're going to go into the demo phase. So we have a docx demo and an explanation about it, so you guys can kind of see it. Then we have a demonstration of this tool with some funny stories that go along with it. And then the exploiting XXE demo. You guys cannot see that. So we're on Bruce Wayne's Ubuntu box today. Because I'm a Batman guy as well. I'm a huge nerd. Alright, so this is just some, we're going to open this up. So this is just some newsletter that I found on the Googles last night. I literally type in newsletter, it's some Google Docs kind, docx, and this is the first one that came up. So they now, due to state funding at Common Core standards, we now have almost 200 Chromebooks. It's cool. Anyways, I thought this was a good one because it has multiple colors, it has multiple shapes, it has many different pictures, and it's got links and all types of goodness, right? So this is essentially a docx file. So what's really cool about this docx file is that you can go in and rename it and just change it to .zip. And it'll change it to .zip. And then from there, you can extract it. So we'll extract it. And then we now see the folders and files that make up this docx file, right? So we have the relationship file. So because this file is so important that if this file is damaged in any way, the whole document becomes unreadable. Or that's the wrong terminology. The software that is parsing it, looking at it, can't read it. We can read it if we open these individual files, but the software itself can't read it, and possibly the hardware that's interpreting it as well. So they hide it by default. So we'll just go ahead and show hidden files, and it's playing peekaboo. There it is. So we open it up. This is essentially what it looks like. So XML version 1, it's got a type of encoding. Then it's got the relationships that it's going with. So it's pointing to these schemas. It's pointing to these are, and this is essentially just standard relationships and schemas, saying if you see this is essentially what the docx file will look like, right? These are the rules that is governing this document. So you open the document properties. Pretty much the same thing. We're seeing the name. It's a template. So this was made from a template called newsletter. We're seeing that it's a total of 2 pages. It has 769 words. It was made for Microsoft Office Word. That's 10 paragraphs, 36 lines, so forth and so forth, right? This is where you're going to see all those cool little, when college students are writing papers and they're like, oh, it's got to be 5,000 words. Like, I am 4,947. Like, what little sentence can I add in here? This is where it's pulling that information from. Pretty much the same thing. So here we are in the core XML file. So we're seeing the last time it was modified, last day it was printed, which was 2014. That sort of stuff. So from there, we actually have, and then we have custom XML. So this is actually that custom stuff I was talking about. And you'll see a relationship as we continue to go down. So as you drill down into it, you're going to have a relationship, if it needs to specify how things are tied together. So this will be the application specific right here. So because we're doing a docx file, it's going to be Word. And then this is where your core file is going to be, right? So these are if you have endnotes, this is where they're going to be. Your headers and footers, if you have numbering or bullets and styles and themes and media, right? So it actually breaks your pictures down. So because you have this file directory, let's say I don't like this paw print, I want a cat print instead, and I want this photo. You can implement that, right? You could say, get rid of image1.png, put image5.png in its place, and then go forth that way, right? So the document.xml file, this file's going to be huge. There's a lot of stuff in it. But this is essentially where you have your text, your headings, your titles, your body, pretty much the meat of your document. This is where it's going to be. So that's essentially a breakdown of a docx file, right? So now, as you can see, that took a lot of work to go into that folder, and then I have to click on the XML file, and then I have to like type my stuff into it. It's pretty tedious. So what do we do when we find things like that? We script it, right? So that's exactly what Will did, and his code is on GitHub. So at the end of my slides, I'll make sure my slides are available. At the end, there are references that I used for building this. And his is most definitely in there, so it has a lot of good, solid information if you find out you're more interested about this topic later. So I found out last night that Will actually released a version 2 of his tool that the ID10T error set in at like 2:30 this morning, and I could not figure it out why I couldn't get it to work. So after many cups of coffee and some push-ups, I was like, oh, okay, cool. We're going to, it's on GitHub, so it does commits. I can just go back, roll it back, and find it that way. But I did want to demo it for you guys and kind of show you a little bit about it. So essentially, you can create a file, right? So you can say what file type you want, and then the payload type. So for our instance, we're going to do a remote DTD, public check. Connect back protocol, you can do HTTP, you can do Gopher, you do mail to file, FTP, whatever you're trying to exploit that you want it to get back to. The host name and IP address and or port that you're wanting it to connect back to, right? The file to exfiltrate. So if you're doing a blind open office XXE portion, you're saying, I want to find this file, but I don't know where this file is. That's essentially where you would kind of put that a little bit. So the standard, what most people do to kind of do a proof of concept is the etc/password file on a Linux box. In the description of the file, then you can specify specific XML for your file format, or you can, if you already have a file that you want to use, you can actually just plug it in there and it'll inject the code in itself, hit build, it downloads straight to your box, and now you have your docx file that you can use. For the life of me, I could not figure out how to get it to work. I couldn't, and I wanted to use this tool to demonstrate how awesome it was, so I didn't just want to copy and paste it in there. So I went back to his first version, and because I knew that worked. So his first version is not as pretty, but it's most definitely effective. It's essentially a Ruby script. So if you guys can make this a little bit bigger. You guys see that? All right, cool. All right, so downloaded from GitHub last night, awesome. So it's Ruby, and it's a Ruby file. TAC B is the flag, meaning that you're going to build a file. TAC F means that you're going to force these changes into the file. And then the dot or the samples and in the sample doc, this is where you could either upload your own, but Will's tool already has like blank examples of many different file types that it could use that you can just use that instead. So from there, it's going to ask what kind of payload do you want. So for us, we're going to be doing a remote DTD. And then payload requires a connect back IP, so I'm doing it on my local box. And then the payload requires a remote file to check for on your server, right? So, excuse me. So all it's going to do is just go to see if it can find that, that file, and then if it finds it, it's just going to shoot back whatever was in that file, right? So I don't have anything for it. I was trying really hard to do the XXE/password because I thought that'd be pretty awesome. With a little bit more time, I could have figured it out. But so for here, we're just going to do payload.dtd. And then it's going to ask where do you want to put it at, right? So right up here, this is the doc type that it automatically generated for us. I don't know where my mouse is. Oh no. Hot corners. So right here, I have doc type, root tag, public, XML, XXEN, and then it's going to call back here and it's going to look for this. So this is actually what it's going to inject into the StockX file. From there, you can insert into all files. You can insert into all files in the same OMXO file. You can create an entity canary. What we're going to look for is the actual relationships because I know for a fact that a parser is going to find it and it's going to go through it, right? So pick that, it creates it, and we're done. We now have an awesome folder, our awesome docx file that we're going to be leet hacksaws with. And then here's our output file, right? Awesome. So from here, now that we have this file, do a little proof of concept a little bit. We're now going to upload it. So, this is like I said before, this is EXO platform. This is kind of used for like internals and internal Facebook. It allows you to share files, obviously, upload files, but also allows you to comment and see photos and do all that cool project management collaboration type stuff, right? So this is one of their older editions. This is version 3.5.5. I think they're on 4.2, maybe 4.3. So as we're waiting for this, how's your guys' day so far?
What was DTD again?
DTD stands for Document Type Declaration, I believe. Description. Here it is.
Thanks.
Here we go. Yeah, so just so you guys can see. So essentially what I set up here, I didn't explain this, I'm sorry. I just set up a simple HTTP listener that's saying listen for any traffic on this port and just output whatever it is. It's a simple web server that allows me to spin it up real quick. So it's uploading, we hit save, and we're getting 404 messages back. We're getting 404 messages back because payload.dtd doesn't exist on the server at this time. But this is an indicator, this is a huge indicator, that this server is vulnerable to XXE. So you know right off the rip that this is something that can be exploited. Now, the level that you want to go into it is totally up to you, but you can do more things. And what's really awesome about this from an attacker standpoint, what's really awesome about this is that there's still a lot of surface areas that haven't been touched yet, that people haven't really messed with or tinkered with yet. So this allows, this kind of allows a little exploration. What's also kind of a good and bad thing is the fact that many parsers are written in like all the languages, from Go to PHP to Python to Java to Ruby. So they're all susceptible to this type of thing. So from a defense side, like I said in the beginning, this XXE is a got me distracted. XXE is something that can be easily defended against. The easiest way to do it is to just turn off allowing external entities in your uploading of your documents. If you see an external entity, don't allow it. That could be pros and cons based on your company's or your organization's requirements, but that's a huge recommendation, and it's simple. It's normally like one line. Like if it's true, turn it to false. If it's yes, put it to no. Restart. So that's essentially XXE. So, does anybody have any questions or comments? Yes, sir.
So the name of the tool is, I guess, is it OXML XXE?
Yes, I apologize. Yes, so the name of the tool is OOXML XXE, and there's a link in the references page right here. It's essentially on this domain. So just type in this right here, and you'll pull up the GitHub page, and it'll have that stuff on there.
And as far as what it's actually doing, is it putting like a macro into that document, or what exactly is it putting into it?
You know what? That's a very good question. Let me actually show you what it injected. So, what's that? So what it, let me see. I don't know how to zoom. Yep, can't do that. So what it actually injected was this right here. So the doc type root tag public OXML. So this is our actual malicious code that it's going to parse. So when it hits it, it's saying, so root tag is pretty much a catch-all. So if you don't know what it is, you just say root tag. So it knows to go to exactly what it is, to the actual root tag. Then we have public. Then this right here is essentially the OXML. So that's saying that we're gonna exploit using this this tool essentially. And in HTTP, this is our actual address. This is our callback. So this is where we're going to send whatever we find back to. And then payload.dtd is the file that we were looking for in the very beginning. So this is where you would put the /password. Or if you knew for certain that there was a particular file on this server, right? Does that answer your question?
Yes. Thank you.
Nice. Does anybody have any other questions? Yes, sir.
So, just like kind of an example from a defense standpoint, say you're running like in JavaScript a parser for this using the JavaScript DOM functionality. Is this just like to defend against it, just something as simple as like going and checking the variable on that like whenever you're running the application? I'm just saying like from a development standpoint.
Yeah, so from what I've read, and I'm still doing research on this as well. So from what I've read, it seems like, let me back up. When I spoke earlier where you have the two classifications, if they were valid or well-formed, I said that there were three types of well-valids you can do. Both of those were external entities. You can actually write your own DTD in that actual XML file, so it's not calling out to anything. It's actually like referring to itself, like it's already preloaded, right? So it parses from top to bottom. So it'll see that and say, okay, I now know how to read this. Doc type, got it, boom, and then just keep it moving all the way through. From what I've read, just not allowing external entities along the way, just turning it off, right? And then from there, your development could come in and say, this was detected. This is what this is what we're looking for, or whatever your error message should be. Does that answer your question?
Yeah.
Nice. Anybody have any other questions, comments? Yes, sir.
So looking at this, I mean, if it's external, that'll allow a docx to become an exploit when phishing without even containing a macro, which allows what we're going to search for. So then also, what you just said was you could write, I guess you could just write the entire script right there inside this hidden rels file inside of docx, so that it might reach out immediately. So you could, I mean, in essence, you're bypassing a lot of filters on any kind of docx that you can fish to a company.
Yeah, and if again, if your filters aren't set up properly, it's zipped. So it's a zip file anyways. Depending on, I guess, the level and the depth that your filters are actually doing these inspection of these files, you're right, it could get passed. I do know there's research going on now talking about exactly what you're talking about, JavaScript, and looking at how JavaScript parses it and how you could use JavaScript along with embedding it into these documents that do XXE that way. Answer your question?
Yes.
Comments, concern? Yeah. Anybody have anything else? Yes, sir.
You ever looked at any other types of documents like PDFs for the changes?
Yeah. So the funny thing with Adobe is that it's proprietary.
Right.
So it does use XML, but it's proprietary. So it's not as open out there. I do know there's stuff on it, but I haven't really done a deep dive into it.
It's extracted out of the files.
Yeah. So I've come to learn in technology in the many years I've been doing it that there's always a way. There's always a way. It's just time, effort, money, and energy. You're going to find a way to accomplish whatever it is that you're trying to do. But no, so docx files are cool. They're awesome. But if you're not going to send a docx file to a client. If it's a final report, you're going to send a PDF or something similar. So PDFs are one of along with Office documents, are one of the ones that, from what I've seen and what I've experienced, that are the ones that are getting, people don't really think about, just like macros inside Word documents. So yeah, so that's most definitely something on my list that I really want to learn more about and dig into. Any other questions? Anything else? Nice. Well, that's all I have. So thank you for coming and listening to me.